Hello, welcome to Maths with EJD. In this video, I'll be talking about the core of cooperative game theory. In the previous video, I had introduced us to this whole idea of cooperative game theory, where you have players coming together to form coalition so they can have uh, optimum benefits from their joint venture or from their agreement. So let's talk about the core now. So what exactly is the core of a cooperative game about? So in cooperative game theory, the core is a set of possible is a set of possible payoffs, actually a set of possible payoff distributions among players where no coalition where no coalition or better still subset of players can improve can improve their outcome by forming a coalition and excluding the others. Now, the idea here is that, of course, you already know that in cooperative game theory, um, you have all the players cooperating. So if there are three players cooperating, so the core of that game is actually the possible payoff distributions, where if any two of those three try to rearrange and form a subset of the main thing of all the players, they cannot get anything better than when they exclude one person. So in that case, we say that's the core of the game of the cooperative game, right? Of cooperative game theory. So I think the idea in a cooperative game is to make sure that the core is available. So once you have the core payoff, in that case, if anybody leaves, the person will be losing, right? So nobody can leave the coalition without losing significantly. So in that case, if you can get the core of anything of any group you're forming, then that helps to keep everybody intact as much as possible. All right. So a distribution of payoffs, a distribution of payoffs is in the core. A distribution of payoffs is in the core if no coalition of players, if no coalition of players has an incentive, has an incentive to deviate from the grand coalition. So the grand coalition is actually the coming together of all the players available. So that's the grand coalition. So if you cannot form sub coalitions and get better payoffs, then in that case we say the distribution of payoffs is actually in the core in that case. So a distribution of payoffs is in the core if no coalition of players has an incentive to deviate from the grand coalition. So there's no benefit for leaving the grand coalition, meaning they cannot they cannot achieve a better payoff. They cannot achieve a better payoff by acting alone or in a by acting alone or in a subgroup of the grand coalition. That's basically what the idea is there. So let's move on quickly to talk about key conditions for core. Key conditions for the core. All right. So the first thing is efficiency. So efficiency is one key condition for the core. So here, the total payoff distributed, the total payoff distributed among all players must be equal to the value of the grand coalition. Of course, this makes sense because by the time they all get their payoff and it's out, it's more than what they contributed to form the coalition. Then that would mean that they are running at a loss or something. So it must be equal to the value of the grand coalition. Okay. So in other words, if the grand coalition is the coalition of all players, the total payoff, the total payoff must equal the value of this coalition. In essence, we are saying that the summation of all i's in n for all the xi's should be equal to v of n. What that simply means is this. Okay, I mean, where n is the set of all players, n is the set of all players, and v of n is the value of the grand coalition. So in essence, we are saying that if you have three players, then x1 plus x2 plus x3 should be equal to the value of the of the grand coalition, right? So it's more like x1 plus x2 plus x3 is the way you should distribute the payoffs so that it is equal to the total worth of the coalition. Okay. Then we have another condition for the core, right? Another condition for the core. This is actually the core, right? Core. So another condition for the core would be that, okay, I guess I want to change markers this time. So another condition for the core would be this. It's called coalition. Okay, let me go green. So another condition for the core is the coalition rationality. Coalition rationality. And what this simply means is that any subset, for any subset of players, say any subset S of players, the total payoff, the total payoff distributed to the coalition must be at least, must be at least as much as the value of the coalition S. So that's the value of the sub coalition, so to speak. So in other words, no coalition, that is a coalition less than the grand coalition, no coalition should be worse off by breaking away, by breaking away, you know, from the grand coalition. So if they have to break away, right, it means they are going with and a fair share of their contribution. of the grand coalition. Okay. So in terms of mathematics, right, that would be that the summation of all the eyes in the sub coalition, so to speak, you know, is actually of all the xi's, their contribution should be greater than or equal to the value of the coalition itself. Hmm. For every s, which is a subset of the of n, n is like the number of players in the grand coalition. So here now we say where xi, of course, we didn't talk about xi the other time. I mean, I just mentioned it, I didn't write it down. Represents, where xi represents the payoff, where xi represents the payoff to player, payoff to player I, and v of s is the value, the total value of coalition S. Of course, the value may be in cash or kind or whatever basis. Now let's look at an example. So let's look at an example of finding the core. Example of finding the core of a cooperative game. So consider a cooperative game with three players, A, B, C, and the following value function. Okay. So imagine that the value for only A is, so if you take A on the player A alone, the value for A is 4. And if you take B alone, the value for B is actually 5. Then if you take C, the value for C is 3. Then on the other hand, if you take the value of AB, if A and B are a sub-coalition, their value together is 9. So imagine if you now take AC, A and C, they form a sub-coalition, their value is 7. Then if you take BC together as a sub-coalition, their value is 8. Okay. And lastly, you have the grand coalition. Imagine that the value of the grand coalition, that's everybody coming together. That the grand coalition is the coalition of all the players, A, B, C. So imagine that the grand coalition, the value is 12. Okay, like that. So just like we see, right? The grand coalition, the grand coalition is A, B, C, and the total value is V of that coalition, the value of that coalition, and that is equal to 12. So if you like 12 million, $12 billion, 12, whatever, any unit you want to use to measure the value. Okay, so let's go step by step and see how we can get the core of this coalition now. So the first thing we want to do is to step one, right? You have to check the efficiency. We said efficiency is really important here. So check efficiency. Okay. So to check efficiency, right, we say that the total value, to be distributed is 12, because that's the value of the grand coalition. So the total value to be distributed is 12. So the sum of the payoffs, the sum of the payoffs for all players must add up to 12. And that is the idea of efficiency. Okay, so if you're assigning payoffs, the sum of all the payoffs should not be less. So in that case, now we are simply saying that XA plus XB, so the payoff for A plus the payoff for B plus the payoff for C should be equal to 12, basically. And this is what we call the efficiency condition. This is the efficiency condition. Okay, this is the efficiency condition. So the next thing is step two. Step two, two things make for the core, the efficiency and then the coalition rationality. So for step two now, we have the so we now need to check, check coalition rationality. Check coalition rationality. So here, now we need to ensure that no coalition, no coalition of players can improve their outcome. No coalition of players can improve their outcome by breaking away from the grand coalition. So that if you have anything less than the total ABC coming together, then they cannot have anything better than that. So we need to check that. So in that case, we have to check step by step. The first one we need to check. So for the coalition, AB, so when A and B form a coalition, which is of course less than the grand coalition. So what do we have? So here we see that the value of this coalition is V of that's V of AB, and that is equal to 9. That is equal to 9. So the sum, of the payoffs of the payoffs for players A and B must be at least 9. So that means we have that XA plus XB is greater than or equal to 9, at least 9. That's what that means. So that goes. So next, we have number 2. We talk about for the coalition A comma C. For the coalition A comma C. So here, we have V of A comma C. We have V of A comma C, which is equal to 7. Given, this is it right here. So it's given in the question. So V of A comma C, V of A B was 9, 7 is AC, BC is 8, which we are coming to later. So V of A comma C, as we see already, is 7. So what that simply means is that we should have X of A, XA plus XC, the payoff for A and the payoff for C should be greater than or equal to 9. Okay. And that takes us to the next one. Of XA plus XC is, sorry, 7, sorry, not 9, 7. That's 7. So XA plus XC is 7. And then we go for the next one. So for the next one is for the coalition, for the coalition for the coalition BC now. From what we're given, the value is 8. So for the coalition BC, of course, here we have this. So for the coalition BC, we have of the value of B, comma C is equal to 8. So that means that XB, so that means that XB plus XC should be greater than or equal to 8, basically. All right. So now we need to solve for the payoffs. So step 3 now, what we have done so far is step 2. Step 3, solve for payoffs. Okay. Step 2 was this. Okay. So step 3 is to solve for payoffs. So here we have, now we have a system. We have a system of inequalities. All right. So the system of inequalities, first one, we have, okay, maybe I shouldn't bother listing. So we have XA plus, or better still, I want to change the marker. So XA plus XB plus XC is equal to 12. Then we now have XA, XA, XA plus XB is greater than or equal to 9. Then we have XA plus XC is greater than or equal to 7. And we have XB plus XC is greater than or equal to 8. Of course, as we already know, this is the efficiency condition. Efficiency condition. And then these three together are the coalition rationality conditions. Coalition rationality conditions. Okay. So with this now, we can solve these inequalities, right? We can solve these inequalities. You can solve these inequalities to find the payoffs, that lie in the core, And that core is what will make none of them pull away. All right. So let's go. We know that from XA plus XB plus XC equals 12, right? We can have or better still, we can express one variable in terms of the others. So here, let's make XC the subject. So you have XC equals, okay, let me alternate. So let's have XC now equals 12 minus XA minus XB. Okay. Now, substitute this XC now. Substitute XC into the coalition inequalities. Of course, you see, you have XC here. You have XC in the second coalition inequality here, here, and here. Okay. You have XC in those places. So can we do that? So let's even rewrite everything. So we have xa plus xb greater than or equal to 9. That's there. Then the second one, we have xa plus xc greater than or equal to 7. So this simply implies that xc now is this expression here, 12 minus xa minus xb. So that's 12 minus xa minus xb, okay, which is greater than or equal to 7, right? So in this case, we can simplify and we have xa plus 12 minus xa minus xb, which is greater than or equal to 7. So this cancels this. So we have 12 minus 7, okay? We have 12 minus 7 greater than or equal to xb. That's if we transfer xb to this side and we transfer 7 to this side. So 12 minus 7 is greater than or equal to xb. So that means that 5 is greater than or equal to xb, which simply implies that xb now is less than or equal to 5. Okay, so we have this result. So with that settled, then we can also substitute into xc, right? The other one. Let's see what that gives us. So okay, so this is the second expression. So we don't have it here. So, but we have it here. So the second case, let's go. XA plus XC is greater than or equal to XB. So now say from XA plus XC, which is greater than or equal to 8, what do we have? So that means we have XA plus 12 minus XA minus XB, okay, is greater than or equal to 8. All right. X, oh, sorry, that's actually BC, sorry. My bad. Okay, so this is XB. So it's XB plus XC. So XB plus XC, XB plus XC. This is XB plus XC. So if we can open this up, so we have XB plus 12 minus XA minus XB is greater than or equal to 8. So this cancels, the XB minus XB is gone. So we have 12 minus 8. That's if you transfer 12 here and XA here. So 12 minus 8 is greater than or equal to XA. Okay. So that means the 4 is greater than or equal to XA. And that simply means that XA is equal to 4. XA is less than or equal to 4. So you have that again. Now that you have these two, right, you can go back to the original expression and then you can now get XB. Okay. So you can go back to the original inequality now. So now it's time to use XA plus XB, which is greater than or equal to 9. So we already have we have XB, we have XA, which is correct. But then, okay, I guess we need to use the original expression. We need to use um the efficiency expression. We now need XC, right? This XC. So we can say therefore XC, which is 12 minus XA minus XB, will now be XC equals 12 minus, well, how do we do this now? I'm trying to see. We need XC now. Okay. Yeah. So let's just assume that those values are actually the actual thing there. So XA, let's take that to be 4. XB, let's take that to be 5. Okay. That's minus 5. So in this case, now we have XC to be equal to 12 minus 9, and that is 3. Okay. So we have those values right now. So in conclusion, right? So if we just take it to if you just take the qualities of all of those things, of course, don't forget this is from the efficiency condition. I could say that. So we say from the efficiency condition, or from that XC we made the other time, we could do this. So in conclusion, right, we have this that in conclusion, the core of this game, the core of this game consists of the following payoff distribution. Okay. No, number one, player A, player A receives 5. Okay. Two, player B receives 4. You remember player A? No, 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 no. Player A, XA is, what is our XA? I guess something is wrong here. 5, 4, 3. Yeah, XB. XB is less than or equal to 5. X is less than or equal to 4. Okay, yeah. So player A should receive 4, not 5. So player A receives 5, receives 4 rather. So player A receives 4. That's what we got. So player A receives 4. Then player B receives 5. Player B receives 5. Okay. And player C receives 3. Okay, that's the last thing we got. Player C receives 3. So at the end of the day, you see that V of A plus V of B plus V of C at the end of the day, right, is actually equal to 4 plus 5 plus 3, which is equal to 12. So it doesn't exceed the value of the grand coalition. Okay. It doesn't end up exceeding the value of the grand coalition, which we have here. The value of ABC, the grand coalition, is actually 12. And at the end of the day, based on what we have, player A receives 4, player B receives 5, and player C receives 3. And that is the core. So if this happens, it simply means that nobody will have any incentive to leave the grand coalition. So we can say that these these payoffs satisfy all the conditions, satisfy all the conditions of the core, and no coalition, no coalition of players can improve their outcome, can improve their outcome by deviating from the grand coalition. From the grand coalition. So, thus, the core of this cooperative game, the core of this cooperative game is 4-5-3, right? 4 for A, 5 for B, right? Is that what we got? 4, yeah, 5 for B, 4 for A, and 3 for C. So that should be 4, 5, and 3. That is the core of this cooperative game. So this solution provides a comprehensive explanation of the core concept, right? We've seen the setup, the step-by-step calculation, and now the final result. So the core of this cooperative game in this particular situation is 4-5-3. And we can easily follow that to solve similar problems. In the next video, I'll be talking about the Shapley value rather, in the in cooperative game theory. So you want to watch out for that. So if you have not signed up to this channel, you want to do that right away. And you also want to hit the notification bell so you can always get alerted each time a new video is released. You want to comment to let me know if all this I am doing are really of help to you. And then You also want to let me know if there's a topic you like me to teach or a problem you like me to solve. And lastly, you want to like and share so that more and more people can have access to this great, great learning. Till I come your way again, keep playing the game of life correctly. Bye.